And this is lead code number 3201. Find the maximum length of valid subsequence 1. You are given an integer array nums. A subsequence sub of nums with length x is called valid if it satisfies the following condition. Return the length of longest valid subsequence of nums. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of elements. So suppose we have an array 1, 2, 3, 4, 5, 6. So any subsequence would be 1, 6, 1, 5, 1, 2, but it cannot be 6, 1 because order should be constant. It's our choice whether we want to take that element or not. We can take or not take this element. We always have choice for every element. So if we do this, we can get any subsequence that we want, but the order should be same as in the original array. So in this question, what it is asking is that we have to find the subsequence that satisfies the following condition. Suppose we have an array 1, 2, 3, 4, 5, 6. In this array, it is asking that if we have adjacent elements and we find the sum of it and do the remainders, all the remainders should be equal. Here it is 1. So it is asking us to find such a subsequence when we do the sum of the adjacent elements and then we do the remainder with 2. We should always get the same remainder. So one thing becomes quite easy. Since the divisor is 2, we will get only 2 remainders, 0 or 1. So the problem becomes quite easy for us. So either the sum of adjacents would be odd or it would be even. There are only 2 conditions. So now in this question, what we can say, either the subsequence would be odd, odd, odd and odd and up to so on, because if we add all the odds, every time we will get even. So if this uniformity is there, we will get even. When else we will get even? If we get even, 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 even. This is first case, this is second case. Third case, when we will get odd? If we have alternates, odd, even, odd, even, odd, even. If we have perfect alternates, then also we will get all the odds. Since it can start with either odd or even, it can start with from here and it can start from here. It depends on the array. We can also have for some array even, odd, even, odd, even, odd. So it depends on the array. What is the starting number that we have and what's the parity of that number? The adjacent thing depends on that. So the question becomes quite easy and the solution becomes quite easy. So what we can do in this question is that, here, suppose we have a array 1, 2, 3, 4, 5, 6. If we can find all the number of odds which are there and all the numbers of evens which are there, we will start with 0, 0 and we will find all the number of odds and evens which are there in the array. So what we can do, we can iterate in the array from 0 to n and we can find the number of odds and number of evens. For each parity, we can do odd plus plus and even plus plus when we find the number of that parity. So the first two cases, the first two conditions, they become quite easy, and we have already done that. We have already found out the number of odds and number of evens. So first and second case is done. Now we get to third and fourth case. Now what we have, suppose the first number is odd, the zeroth index is odd. So what do we require here? We require that the next thing should be even, and next to that should be odd, and then even. This should be our approach. So how we will manage that? We will take a last counter of type integer. So we will set the last counter to be opposite the parity of the zeroth index. So if the zeroth index is odd, we will do last as even. Suppose 1 2 3 4 5 6. So this is a perfect example of third and fourth case. So it starts with 0, it starts with odd, it starts with 1. So in this case the parity is odd because the zeroth index is odd. In this case, what we can do here is that since the parity of first one is odd, we will go to the second one. We will check what is the parity. It's even, so it's useful for us. Then we will check the next parity. It's odd, then even, then odd, then even, and up to so on till we will find the next things. So what we will do here is that for the first element we will do the last integer to be opposite of the odd parity. We will put it 0. Suppose we are taking 0 and 1 as two values of last. We will give 0 to even and 1 to odd. So last, if we have odd, we will take last as 0. So in this case, if the last is 0, for the first one, this becomes, if we come on this, we will see that, oh, the last one was 0. So now the parity is odd. So we were getting alternating. So we will do the last to be odd. So odd was 1. And do answer plus plus. And then we will go to next element. We will see that the last was 1. This was 1. This thing was 1. And now we are on this. So last was 1, which is opposite. So it is alternating. So we will again, what we will do, we will set the last to be the current element, which is 2. So its remainder would be 0 with 2 and answer plus plus. So this would be our approach. So let's look at the code. So in this code, we have taken odd, even and alternating to be 0 initially. We have taken the parity of last to be opposite of what the first element is. If it is 0, we are taking it as 1. If it is 1, we are taking it as 0. So we are deducting 1 from 1, we are deducting the parity of the 0th element. So here what we can do is that so we will take a for loop, and in this for loop, if it is odd, we will do odd plus plus, and then we will see if the last element was even. If the last was 0, we will do alt plus plus, and we will put the last element to be odd, which is the current element. So if it is even, we will say if the last was odd, so we will do alternating plus plus and last to be the current, which is even here. So here we will return the maximum of alternating odd and even. Let's run this code. What we have done wrong here? Okay. So it has successfully been submitted.